everyone. My name is Michelle Muzzio, and I'm an editor at the Cell Press Open Access and Interdisciplinary Focus Journal titled iScience.
And hi, I'm Kristina Vrouwenvelder, and I'm an editor at Cell Press's flagship general chemistry journal, Chem.
Together on behalf of Cell Press and the quarterly newsletter, Research Arc, geared at bringing cutting-edge research content into the hands of industry professionals, we are excited to interview today Professor Jin Xuan from Loughborough University on the intersection of the circular chemical economy, bridging academia and industry. Professor Xuan has many accomplishments, but in brief, right now, I'll just say a couple of them. He holds a chair in low carbon processes and is the head of the Department of Chemical Engineering at Loughborough University. Professor Xuan is currently leading the £4.5 million UKRI Interdisciplinary Centre for Circular Chemical Economy, working with more than 100 industrial partners to transform the UK £35 billion chemical industry into a fossil-independent, climate-positive, and environmentally friendly circular economy. Professor Xuan is the recipient of the BLB Medal and Prize in 2020 jointly from the Society of Chemical Industry, RSC, and Institute of Materials, Metals, and Mining for his work on reaction and thermofluids engineering, the aim being to achieve clean growth, sustainable development, and industrial decarbonization. Thank you so much for joining us today, Professor Xuan. We're really excited to have you here, and we'll start the interview now, so thank you.
Yeah, thank you. So first, I want to just start with an easy one for our viewers to just kind of get introduced to you. So you're the director at the National Interdisciplinary Centre for the Circular Chemical Economy. And could you just talk briefly about your role here, and as well as talking more specifically about, the interface of academia and industry that you're trying to facilitate with this?
Thank you much. So the Circular Chem Centre, which I'm leading, is part of the £30 million UK government investment. So the centre is playing a key role in helping reduce waste and minimize environmental impact of the production and consumption of chemicals. We also want to create opportunities for the new chemical industry within the UK and also globally. I'm very, very excited to have a chance to lead the centre and bring together more than 100 stakeholders from academia, industry, government, NGOs, general publics, to transform the UK's chemical industry into a circular economy. So regarding the interface between academia and the industry, we are working with a very large number of stakeholders. They have been involved in the co-creation of every solution being delivered by our centre. So in our centre, we adopt a so-called stakeholder-based participatory approach to ensure close collaboration with industry and consider the global context of our research activities so as to maximize the impact of our research across technology, social, and economic perspectives.
That's really interesting. Thank you for talking about your different stakeholders and how you organize it. I can imagine that's a really difficult process to have to do. I was really curious in general, what you thought is the role of sustainability centers or also university-driven sustainability initiatives in inspiring action, and what are the biggest hurdles? I think obviously facilitating a lot of discussion is probably a big hurdle, but what are the hurdles considering such centers?
Yes, so I think like university-based research centers like us play very important roles in driving our sustainability agenda across wider society. So first of all, we all agree that we are naturally the leader in generating knowledge and accelerating solutions to enable sustainability transitions. And in most of the cases, we cannot rely on incremental improvements to realize sustainability transition. Instead, we need to look at disruptive technologies to completely change the way how we use resources, we use energy, the way of production, consumption, and end-of-life treatment of chemicals, which need fundamental research to make them happen. And definitely we play a very important role here. And also, we can also provide national or even international leaderships in coordinating and driving the knowledge exchange across sectors. No one else, I think, can play such a role like us. But I think that's also where the biggest hurdles are. We need to be very careful to ensure our research is embedded with stakeholders by involving businesses, policymakers, consumers, and society, the third sectors, and any other affected groups and communities for everything we do, so that we ensure the solution is actually applicable to the wider society.
Yeah, that's great. I think you touch on a lot of important points in sustainability already, from, not just looking at the energy use during, production, but also looking at the end of life of products. So I think this brings us to our next question. What does sustainability mean to you? And do you think the definition of sustainability changes across academia and industry? And if so, what are the differences that you see?
Sustainability to me is about systems thinking, which means to assess the sustainability of a new technology, a process, or service, we need to gain insights into the whole systems around such technology, processes, or services over the entire life cycle, as I said before, instead of just looking at a single point performance. And sustainability will only be able to assess by means of system-wide approach, which combines economics, environmental, and social impact indicators. And I think the definition of sustainability should be the same across academia and industry, but there might be some different focuses. So for example, when we talk to industrial partners, it becomes very obvious and clear that the economic viability is a fundamental condition for businesses to engage with the circular economy or any other sustainability transitions. So many businesses do want to do the right thing, but it can be very difficult for them to implement change if the solutions are not commercially viable.
Yeah, I think you brought up a couple really good points with the different focuses, where the definition is kind of set, right? Where what are these different things that make up sustainability, but what people or what industries have to focus on varies really greatly. And there's a bunch of different considerations that you brought up. So I think with that, what do you think are the biggest sustainability challenges facing the chemical industries today? We talked a little bit already about emissions, end of life, feedstocks, solvents, potential pollution. What are the biggest sustainability challenges?
All right, so the voice from the chemical industries is very clear. So unanimously, the biggest motivation for our industrial partners to engage with us or to shift towards a circular economy is the unacceptably high carbon emissions associated with the sector. So it's all about the carbon emissions. It's commonly accepted now that the chemical sector does not have the option of business as usual as we transition to net zero, because the current linear approach is simply not compatible with the UK emission clean growth policy. So we have to do something here on the emission or the net zero nature of the industry. But having said that, we will also take a systems approach to consider other sustainability issues and challenges, such as the things you mentioned: environmental pollutions, biodiversity, waste generation, water usage. All of these associated with the life cycle of the chemical value chain, because all these challenges are closely interact with each other.
Yeah, I think that's, I think you've touched on a lot of great points, and, speaking towards, economic viability and making that come into line with carbon emissions is a really important question, and one that I hope that your institute will help us answer. And that sort of brings me to the question is, what do you and your institute see as the route forward to a circular chemical economy? Thinking more generally, not just about emissions, but maybe even also about some of these other side issues. Is there just one route? Are there multiple paths? And can you speak to what you see as the future here?
Well, I think it will have to be multiple paths, because the chemical sector is such a diverse sector. So nowadays, nearly 140,000 fossil-derived materials and chemicals are in the market. So you cannot find a silver bullet to make all of them sustainable. So you have to look at multiple paths. And one of the potential solutions we are looking at within our center is to look at the circular economy solution for platform chemicals such as olefins, because olefins are the raw material of more than 70% of or organic chemical production. So you can imagine if you make olefin production to be sustainable, then you naturally solve the most of the problems. But still, we need to look at multiple pathways, even for the sustainability around olefins resources flow, because you can, for example, look at various feedstocks, such as captured carbon dioxide, the waste stream, or biomass resources for different ways of production for olefin production.
Yeah, thank you for that sort of insight into what your center is looking at. Are those the technologies and research areas that you're most excited about, or where do you see where there's the most potential and potential for growth in the next decade or so?
Oh, well, my answer will be most biased because I like my personal research very much. I like the research I'm doing at the moment. I'm really, really passionate about developing and applying bespoke artificial intelligence and digital solutions to enable the next generation of sustainable chemical processes and systems. I do see a lot of potentials on the digital transformation of complex chemical processes through, for example, integration of smarter sensors, advanced simulations, and data-driven deep learning, those kind of things. And my vision, or what we're trying to achieve in the center, is to deliver a paradigm shift in how future chemical processes can be designed, optimized, and even self-evolved throughout their entire life cycle, so that we can maximize the sustainability and the value creation at the same time.
Yeah, thank you so much. I think, digitalization, it sounds like it has so much promise, and I hope that we'll be able to see that achieved for many reasons. So yeah, thank you so much, Professor Xuan, for joining us today. This was a fascinating conversation, and it was our honor to speak with you. To the viewers, thank you so much for tuning in, and we hope you can check out the related content to this interview in our Research Arc newsletter, as well as in our journals.
Thank you very much.